Hi to all, this is Karl Marbaise speaking with a lecture about JUnit Jupiter Extensions writing end-to-end tests. If you like to contact me, you can do that via Twitter, via GitHub, or via email. Take a look on this slide. So, some words about me. I'm working as a German freelancer, working with different technologies like Java, Docker, Jenkins, Spring Boot, and so on, as you see on the slide. So, the agenda for this lecture is about the example application. We would like to end-to-end tests, how it looks like, and so on. Then we will see how JUnit Jupiter platform looks like, how to use it. Writing some unit tests with JUnit Jupiter, what are the details here and what is needed or not. And then finally we start with the running end-to-end test, what is needed to do some real end-to-end testing. And then we start writing an extension with JUnit Jupiter to run those end-to-end tests. And finally, we have a Q&A session. At the beginning, we need some example application which we like to do some end-to-end testing on. I have decided to use a Spring Boot application, very simple one, of course, for simple purposes. Has 2 REST API endpoints and things like that, and writes to a database. In this case, I'm using a Postgres database, and we will take a look into the code later. Just going to the code now. So here in the code, we are starting with the Spring Boot application, main application part, which is very simple here in this case. We have 2 controllers here. We have a simple Hello World controller. I call it Hello Controller, very easy. Then we have an employee controller. We have 2 different endpoints, one which is create and one which is lists. The first one, create, will create with each call, with each post call, a single entry into the database, where the lists endpoint will just list all the entities which are existing in the database. So this is the connection to an external service which we need to run our application here. We have, of course, our employee entity defined. It's very easy, very simple, very basic. Nothing fancy here at the moment. So we are starting that, and we have now an application. I have to decide a little bit larger project, which comprises of 3 different modules: application, E2E, and extension. About E2E and extension we will talk about later, and now we will start and take a look how the JUnit Jupiter platform looks like. So now we are taking a brief look into the architecture of JUnit Jupiter platform, which comprises of 2 parts here in general. There is an engine, usually the JUnit Jupiter engine in the middle, written in green, and the platform. Those 2 parts are communicating with each other. So we have the JUnit Jupiter engine, which is responsible for finding tests, identifying what a test is and how it looks like, and then give back the information to the platform, which then uses the engine, the platform runner, to execute the tests. This decouples completely the IDEs and build tools from the identification of tests and finding out what a test is. Sometimes it's useful or necessary to filter out some of the found tests, but based on particular filtering criteria, that can be done as well. And then you have a complete decoupling via the platform from the engine and your real tests. If you take a look on the left side, you see the vintage engine, which is responsible for running the JUnit 4 tests and identifying them, of course. And that means you can combine JUnit 4 and JUnit 5 tests into a single project, which is possible. It's very convenient for migration from JUnit 4 to JUnit 5 only tests. So on the right side, you see another option that you can implement your own test engine, identify tests and things like that. And if you have done that correctly via the interfaces which are existing in JUnit platform, then you have automatically integration into your IDE and build tools without supplemental implementation. So that makes it very easy and very comfortable to use that engine. Most of the time you don't need to implement your own engine, but it is possible here. So going to unit test. Okay, into the unit test. So we have here a simple unit test which contains 2 unit tests, like first test and second test, which are annotated with the appropriate test annotation. So sometimes it happens that you need to do before each test something, set up something, or initialize something. That can be done and simply achieved by using the before each annotation with an appropriate method. If you need to do something going down after that, you have to use after each with the appropriate method. If you have a necessary setup to be done before all the tests only once, then you can use before all, which needed to be a static method based on the part that the instantiation of the test class, in this case the standard test class, is done for each test separately. So you have to do that into before all or after all if you're going down with something like that. So that would be the first. So now let's assume and think about what is really needed to do run really end-to-end test. We have to start all the parts which are needed for our application, for example, a database or Redis or something like that. Then we have to, of course, start the application itself. Then we need to do the testing, whatever we do, accessing the database, accessing REST endpoints or whatever. And then, of course, finally, we need to shut down the application itself. And last, we have to shut down the other parts, like the database or Redis or whatever we are using here. Okay, now let us translate these steps into real annotations which are used by JUnit Jupiter. You see the part before each. We need to start up all the components, start up the application, then doing the test in the real test method, which is annotated via add test, of course. Then after each, we have to shut down the application and shut down all the components we have. If we think about that approach, it becomes clear that you are writing a lot of code inside your before each and in your after each method. For starting up the application, for starting up the dependencies like database, like Redis or something like that, and for the after each method as well. So it becomes not very clear where the real test code is, and it's a little bit cluttering the test cloud with application component setup, shutdown code, and so on. But on the other hand, it's very easy to do so. So we might think of a better approach here. A good solution could be using JUnit Jupiter's opportunity to do some so-called extensions. JUnit Jupiter has a lot of extension points where you can intercept different calls of different methods. For example, the before each, after each, before test or something like that. Let us take a look on a more clear diagram. So if you take a look here in a simplified order of the calling, you have different calls like before all callback or before each callback or before test execution callback. And then the parts which are marked orange here. That means the before all callback method is called before the before all of the user code. And furthermore, the before each callback is called before the before each call of the user code in your test. So we can intercept these different points here and get an interception into that and, for example, start with an before each callback and start our application, for example, and the needed parts here. And in the after each callback, we can do the same thing here and say we stopped our application and the needed parts. So that's the way we will go, and we'll start with that, and you will see to go via an extension, which is using these things here. So now we are in the code. I'm starting with the example of my end-to-end test as an example. Here you see the test method which I have defined and which is usually annotated with the add test annotation. But you see also an annotation which you can't be familiar with because I have defined it on my own. This is the E2E test annotation which I have defined here for running these end-to-end tests here. That looks like this here, and usual annotation part where I'm allowed to put that. And a very important thing here is these extend with, this is the part where to enter the area of JUnit Jupiter. This is a definition of a class, which we can look at. Just going back. And then you see the class which I have using here is this E2E extension. We are starting with defining some callback interfaces here. Let's start with the before each callback. That's simply an interface which contains only a single method, which is the entry point before each, as we've seen on the previous slide. If we take a look how it is implemented here, we start with the database container as described in our lectures here. Then we start our application in several ways here. I will explain that later in more detail. Then start up and wait until it's started up. The same thing we have to do is to shut down the application, which is done by using the after each callback here. So after each, then we stop the database here. This could be much more than just only a database that you can use and stop anything, any of the components you have used here. And then I'm ready with that. So let us start that on the command line first and see how it works. That will take a few seconds here. I'm creating here a multi-module build, I already said so, and running that via a supplemental profile here. We will take a look later at the configuration, how it looks like. Okay, started, and you see 13 seconds or something. So let us take a look what is really happening here. I've created a separate module where I have the real test here, and I have a directory created here, and you see that there is a method name or directory called first test. And in that directory you will find the application standard out. That means the startup of your complete application, in this case the Spring Boot application with all the information you need. I have standard error, which should be usually empty. I have created a GC log, which is the case because I have configured that into the startup information on the command line of the application. And then we can take a look how that really works. If you want to know some other stuff here, you can take a look, because I'm using Maven here, in the failsafe report directory. There is an output text file that represents all the output which had been created during the startup session here. There you see the startup here of Docker test containers here, that a Docker container is started. And if you're going down there, then you see somewhere here is the startup of the Postgres database. Then you see this Postgres database. So it's downloading that, takes some time here. And we go downstairs here, going down through the file. And then we can see somewhere the check if our container is running. That means if our application is running. We are using the health check of the application and just polling that against that and waiting until it's really ready. Because most of the time, most of these services today have a health check and can be easily used for such things here. If it is up there, then we know it's up there, and then you see the system out printle, which I have put into the example output here as described here. So now how it looks like all this stuff are working in the extension. So we have two more things here which are very important. The database container is one of them. That means we have a class here, very simple, which contains a start method, which uses test containers to start up a Postgres image here. We are exposing a port. We are trying that several times to be a little bit more safe. We make a timeout in cases there's going something wrong. Then we are defining some environment variables to define the username, the password, and the database we are already using. Then delegating to test containers. We do the same thing for the stop method and some other things here. Then we can use that and start up that in our extension, and then simply wait until it's started. That is a synchronized call in this case here, and we wait until the database container is completely started up. You can start in that way, for example, other stuff if you like in Redis or whatever you like here, that would be possible as well. So we created some directories where we store the resulting standard output information and things like that. That is created by these constructs here. We are getting some information from the context here and creating based on that directory names. So we can create the storage here in a supplemental directory to make a separation between each test run. Then we have application ports, which is important to create different TCP/IP ports. Simply using that and using the socket utils from Spring Framework, and we getting two different ports here and defining two different ports, one for the application, one for the actuator here. The actuator is exactly the point with the health check here, make them separate and give them back to my extension here. So in this case, we are using the ports, creating them, and then putting them on the command line to define the server port and the management port. And also getter methods have been defined in the database container to get the information from the URL, how it is produced and how it is created. One word, supplemental word about the mapped port. If you start a container on the command line and use a -P, automatically a TCP/IP port is selected, which definitely not clash with other ports. If you do that manually and do that twice, you will get a clash between the ports. So that can clash sometimes, and usually should let Docker do that here in that way. Then we have started up our application. So one thing is needed to do is to start up our real application here. And that's why I created this application executor called. That's getting the information of the directory where we should start inside there and how it is named the application. Technically, it's not doing something special. It's just starting up and using the Java home with the JVM, just checking if the existence of the file is there. You see there are the JVM arguments. That's the reason why we get an GC log or something like that. That can be changed, of course, for your requirements. Adding some supplemental calling arguments like the java-jar or something like that, the startup arguments for Spring Boot, printing them out on the logger to have more information in cases of errors, and then starting via a process builder, this part here, redirecting error and start it out, and setting a working directory here for that. And after that, you can start the application and wait until it's up there. And the thing here is ready is simply using the REST endpoint, meaning the actuator help check endpoint, to wait until it's available, the application. That can be done in different ways depending on your application. This one, I think, works with mode application because many applications today use our actuator for something like Prometheus or something like that as endpoints. Then you can use the health check endpoint for that to wait until the application is started. Going down after each as well here, we wait, shutting down the database and waiting until the database is down. The application is shut it down via a kill signal, and then we wait until it's completely down. The details I will take a look later. So the result is that we get the information here from the output all the time here, and I can see that it started up correctly. And if I take a look into the output, which is created by the failsafe plugin, then you see all the stuff and the health check is done, and also the information is printed out that my method has been executed. So one thing here is, if I do that way here, I can very easily start up a second test without a big issue here, just simply doing that. And if I do that a second time here now, that will take some time, of course. So that takes a few seconds here to start up that part here. So you see it took 24 seconds because we have started two tests. That means the complete application plus the database container has been started up completely 2 times. Just sequentially, but that has been done. So you can see the results here. One application startup log here, and a second one is now created. And you see the same thing here. now you have the possibility to intercept the information and the startup of the application via the usual setup, which is already there via before each. So we can intercept that and start in before each doing some special stuff if we like to for each of our application. That means for two of them in this case, I do that here and just calling the REST endpoint of my application here and just creating supplemental entries for the database here, just calling the create endpoint here and just printing out something. For a real use case, you should do something different instead of printing out something. So I can rerun that and then you can see the result of that. That will take a number of seconds. These are 30 seconds, around 30 seconds, which takes the time here. Yes. So you see 25 seconds, and then you see things like that, and then you can see in the output here that if you take a look in that, you see the health check here, then the running here, or in the log file. That will take a time, and then you see that the health check of the second call is done here, and you see that the create endpoint is called several times here. Furthermore, it's also called the lists endpoint here is called, and you can see that the information is given back from our application. So you can use that for whatever purpose you like. So furthermore, there are some special things here to get that internally correctly running here. There is a so-called internal storage, which is used here that I said before. I store that here into a so-called context here, which is provided by the JUnit Jupiter framework. Internally, this store is more or less a hash map, which is synchronized, and you can use that in multi-threaded environment. You should use also a namespace for your own extension, usually in the name of the class, including the package name and so on, and then get that store, and into that store you can put information. There is a big difference here. You can use that, and you should use also a unique ID. That is a combination of the engine which is run, like JUnit Jupiter and things like that. And this information includes also the method name. That means this information here is stored by using that, which includes also the name of the method which is called. For example, first test, second test in our class, including the class name, of course. And that means you can store the information of the database container, and that means in consequence that you can completely run this here in parallel. So it is possible to do that if you do that correctly with the store here, that you can run all the tests in parallel. And that's a very good thing, in particular if you run such complex and time-consuming end-to-end tests, you can run them in parallel if you like. But you have to be a little bit careful what you exactly store and how you exactly extract that. Usually there is no choice, no way to give some information from before each to after each. And using a local variable is a bad way because it does not work and it's not thread safe, of course. And using that storage is the only correct way to do that. And then you can use that into in your after each, for example, get an instance of the class database container, for example, to stop that, also from the application process, which is stored at the before each method as well. So this makes it possible to run them in parallel. One more thing is to support parameters here. Then you have to add an interface implementation, which is called parameter. Parameter resolver, sorry. And these things are used to check if the parameters of before each or the test method itself contains particular parameters which are supported. And then you can check the parameters here, for example, application port, database port, and put these informations from the storage into the methods which are returning that as an object here. And that means it is possible to have these things here just writing that into your test and inject into your test very easily. So now let us a little bit improve the speed here of that test here. So I have prepared something a little bit here, and now I run that, and you see that last time you ran that took about 25 seconds. And now we have two tests running, but they're running in parallel. And you can do that with much more than of them, with much more tests, end-to-end tests if you like. But that depends, of course, on your machine, how many cores you have, how much memory you use, and things like that, and how many components you are starting up or shutting down. Then it can increase the speed a lot. And you see I'm coming down to the speed with 15 seconds as before, but I'm running two in parallel. And that's, of course, possible here as well. So you have a very easy way to separate that. As you see, I have implemented the extension into a complete separate module. You can do that in the before each, after each method yourself the first time, but it's not a clear separation of concern and not clear separation of the code. I think it's better to use the separate module for that, because that makes it easier to extract that and put that into a separate project, which can be easily reused somewhere else if you like. It's also furthermore possible to make different extension. I have combined at the moment the extension for the database as well as the application. You can do and make separate extension of that. For example, one for the database startup and shutting down, and a separate one for the application startup and shutting down. And then you can make it more flexible to combine them. But that depends on your use case here. So let us come back to the slides. For example, as I said, different things here as well possible. And finally, I think if you have further questions, the Q&A session will be coming there. I have some links about the documentation, which I strongly recommend. The user's guide. I have made a lecture last year on FOSDEM as well about basics of JUnit Jupiter, the user's guide, extension execution order, and things like that. And of course, a link to the whole code, which can be seen on GitHub here as well. Thank you very much, and we will see you in the Q&A session.